The question says you have mercury to a level of 70 centimeters. The pressure that this much mercury exert, if you want it to be exerted by water, okay, so if you want this pressure to be exerted by water, what should be the height of water column? Okay, so for that, what information we have is what is the pressure due to mercury column? That is height of mercury, density of mercury into gravity. And what is the pressure of water column, height of water column, density of water column into gravity. So this is cancelled. Some information that will be used over and over again, that is density of mercury is 13.6 into 10 to the power 3 kg per meter cube, and it is 13.6 gram per centimeter cube. That for water, density of water is 1000 kg per meter cube, and it is 1 gram per centimeter cube. So here the height of mercury column is 70, the density is 13.6. So this is 952 is height of the water column. So height of water column is 952 centimeters. So you can see that to balance 70 centimeters of mercury, we require 952 centimeters of water column. That's a pretty tall affair. Now B part, the question is asking you that if you have a wider tube, will that affect? So students over here, pressure is equal to H rho G. So pressure depends only on the depth. It does not depend on the width. So answer is no. Pressure will not be affected by width of the column. Okay, so moving ahead to the next question. This is ground floor. The pressure over here is 40,000 Pascal. This is first floor and the pressure is 10,000 Pascal. So they are asking for the height. So over here, the pressure difference. So if I call this as P1 and this is P2, okay, let me write over here. P1 is 40,000 Pascal, P2 is 10,000 Pascal. So we have P1 minus P2 will be H rho G, the height of the first floor that is. So we have 40,000 minus 10,000, that is height. Density over here is the water, which is 1,000, and gravity to be taken as 10. So we have 30,000, this is height. So we transfer the other things here 1, 2, 3, and 4. 1, 2, 3, and 4. So the height goes to 3 meters. The height of the first floor is 3 meters. Moving to the next question. So this is a tube that is connected. Both the ends are open. Mercury is filled. Since both the ends are open, the level of mercury in both the tubes will be equal. The question is that on one side, you are adding water. The amount of water that is being added is 13.6 centimeters. Now, obviously, that is going to add pressure, and that is the reason why there will be a rise on the other side. Okay, so how much will be the rise is the question. So, as we have done earlier, the pressure exerted by water column will be equal to the rise in column for mercury. Okay, because this thing is mercury, and this is water, which is exerting pressure. So, G will get cancelled. So height of water column is 13.6. Density of water is 1. Height of mercury column we need to find, and its density is 13.6. So this cancels out, and therefore height of mercury we get it as 1 centimeter. So that means to balance the pressure exerted by 13.6 centimeters of water, the rise in mercury column will be just 1 centimeter. Okay, that needs to be written like an answer. Okay, moving to the next question now. This is the third type question. So where there are two pistons, one with a smaller area, one with a larger area. You don't need to draw the diagram. I'm drawing it to make you understand. So here you have a piston, and here there is another piston. So this piston is exerted by a force of 2 Newton, and it has an area of 10 centimeters square. This has an area of 100 centimeters square. So how much force will it experience? So how do we write it? We have F1 equal to 2 Newton, A1 equal to 10 centimeters squared, F2 equal to question mark, and you have A2 as 100 centimeters squared. So we have to write by Pascal's law, we have F1 upon A1 is F2 upon A2. So that will be 2 by 10 is equal to F2 upon 100. So therefore we get F2 as 2 upon 10 into 100, and that's what gives us 20 Newton. So that means the force experience on the other piston will be 20 Newtons. The next question is similar to this. So we'll do that now. Question number 9. They have given the force experience on the smaller piston to be 0.5 Newton, and the one on the bigger piston is 15 Newton. And they are asking us to find the ratio of the area. Again, we write by Pascal's law, we have F1 upon A1 equal to F2 upon A2. So we get F1 upon F2 is A1 upon A2. And here we have 0.5 upon 15 is A1 upon A2. Now when you have 0.5 upon 15, so that will be 5 over 150. So 5 ones are and 30. So you get 1 over 30 as A1 upon A2. And that is the reason why you have A1 is to A2 as 1 is to 30. So the ratio of area is 1 is to 30. Okay, do not leave the answer as a fraction, write it like a ratio. Moving ahead to the next one. In question number 10, the area A1 is 5 centimeters squared, A2 is 625 centimeters squared, and they have given F2, the force experience on a bigger piston, that will be 1250 Newton. Okay, though this area is given in centimeter square, we do not need to change it into meter square because it is a ratio. So again, by Pascal's law, we have F1 upon A1 equal to F2 upon A2. So we write F1 upon F2 equal to A1 upon A2, and F1 upon 1250, that will be 5 upon 625. So this will be 5 upon 625, and 1250, this will be 2 So we get F1 as 10 Newton. So that is the force experienced on the force exerted on the smaller piston, so that the force experienced on a bigger piston is 1250. Okay, let's move to the next one. In question number 11, in all these questions, the assumption as the Pascal law says that the liquid is a confined liquid. Okay, it is inside the cylinder. There is no leakage to these cylinders which are connected. Then only the Pascal's law will be followed. Okay, now in question 11, they are saying that there's a bottle. So if you see a bottle which looks something like this, so this end is also a circle, so is the other end. Okay, now there is a liquid confined inside the bottle. So if you apply force F1 on this area A1, then the force experienced over here is F2. And again by Pascal's law, it will be F1 upon A1 is equal to F2 upon A2. So here we have diameter 1, which is 2 centimeter. Therefore the radius will be 1 centimeter. Diameter 2 is 10 centimeter. So the radius 2 will be 5 centimeter. Now the ratio of area A1 upon A2 will be pi R1 squared and pi R2 squared. So this pi and pi will get cut, and we have 1 squared and 5 squared. So therefore you get 1 upon 25. They have also mentioned that F1 is equal to 1.2 kilogram force. So therefore, by Pascal's law, we have F1 upon A1 is equal to F2 upon A2, or we have F1 upon F2 is A1 upon A2. So we get 1.2 upon F2 is 1 upon 25. So F2 is 1.2 into 25, and that will be 30 kilogram force. So when you apply 1.2 kgf on the bottle, the other end of the bottle will experience 30 kgf. Okay, so we have been given that F1 is 50 kgf. They are asking us to calculate F2. Now the diameter is 5 centimeter, so therefore the radius will be 2.5 centimeter. The second diameter is 25 centimeter, so the radius will be 12.5 centimeter. Like we did in the previous question, if you want to calculate the ratio of area separately, so this will be pi r1 squared and pi r2 squared. So this is getting cancelled, and this is 2.5 squared and this is 12.5 squared. So if I write it as 2.5 and 12.5 the whole square, which is 25 upon 125, we know that 25 ones are 25 fives are. So that is 1 upon 25. So we have A1 upon A2 as 1 upon 25. Now this we will use when we apply Pascal's law. We have F1 upon F2 equal to A1 upon A2. So we have 50 upon F2 is 1 upon 25. So F2 is 50 into 25. So that will be 1250 Newton will be the force experienced at the bigger piston. Okay, let's move to the next question. In question 13, again there are two pistons. So the area of the smaller piston is 8 centimeter squared and area of the bigger piston is 320 centimeter squared. Then they have said that on piston 1, there is a mass kept of 4 kg. So therefore the force will be 4 kgf. Okay. They are asking for the pressure on piston 1. So pressure is force upon area. So this will be 4 kgf upon 8 centimeter squared. That will be 0.5 kgf per centimeter square. That will be the pressure. Now, if you want to write it in SI unit, the value of G must be provided, which is not given in this question. So if they have given G as 10, then you could have written this as 40 Newton because 4 into 10, and this will be 8 into 10 to the power minus 4. So 8 ones are 8 fives are, and this will be 5 into 10 to the power 4 Pascal. Okay, so that will be the conversion. Okay, provided the value of G is given to you. The second is pressure on piston B. So likewise, over here, pressure which is force upon area. Then for this one, we need this 0.5 kgf per centimeter square. Okay, why? Because by Pascal's law, pressure is transmitted equally and undiminished everywhere. So therefore, pressure on piston A is equal to pressure on piston B. So on piston A, if this is the pressure, so piston B also will have the same pressure. The third one, the thrust on piston B. So pressure is thrust upon area. So this we have 0.5. So this is F and this is 320. So F will be 0.5 into 320. We get F as 160 kgf. So 160 kilogram force is the force experienced on piston B. Okay, let's move to the last question. Okay, so in this question we have A1 is 2 centimeter squared, A2 is 12 centimeter squared, F2 is 150 Newton. We have to calculate F1. So by Pascal's law, A1 upon A2 is F1 upon F2. So 2 by 12 is F1 upon 150 So that is 2 by 12 into 150 is equal to F1. 2 ones are 2 sixths are. So this will be 25 Newton. So the force experience is 25 Newton. Okay, in the next video, we're going to see some more numericals. Thank you.